All right, everybody, let's take a look at section 1.4, problem number 22. Now, in this problem, they gave you one piece of information about an angle theta, and that's that its cotangent value is equal to 4. And they wanted us to come up with 3 additional pieces of information: sine of theta, cosine theta, and secant of theta. The wrong way to approach this problem, everybody, is to think that you need to figure out what the angle is, theta. You'll see some people who try to do inverse cotangent on the left and inverse cotangent on the right, and try to figure out what theta is, and then try to answer these 3 questions from there. What the people doing the problem that way are missing is the idea that's important here is that once you know one of the trigonometric ratios of a particular angle, that tells you 2 of the 3 pieces that we know. Here's what I mean by that. If we know, and this is something that a lot of calculus students have hesitated to memorize over the years, but you gotta have this down. If we know your x, y, r definitions of sine, cosine, and tangent, that helps you through this problem. Sine of theta is always your y coordinate divided by your radius. Cosine of theta is your x coordinate divided by your radius, and secant is always the reciprocal of cosine. That's going to be r divided by x. Now, what we've been given up here is cotangent. Cotangent is the reciprocal of tangent, and one that we didn't write down just because they didn't ask us to in this problem. Tangent of theta is always y divided by x. Cotangent, therefore, is the reciprocal of that, which is x over y. Now, if I look at the whole number 4 as a fraction, of course, I can think of that as 4 over 1, and that tells me 2 important things about this ordered pair. Its x-coordinate is 4, and its y-coordinate is 1. So I'm going to go ahead and write those 2 pieces of information down. X is equal to 4, and y is equal to 1. Now, once we know the x and the y coordinates, we can always find r, the 3rd piece right there, by remembering one essential piece of information that shouldn't escape us at any point here, guys, that the Pythagorean theorem always applies. X squared plus y squared is always equal to r squared. And if you recall, everybody, let me just draw a point in the first quadrant right here. Anytime that you make a triangle out of a point here like this, your x coordinate is that horizontal leg, your y-coordinate is the vertical leg, and then r is the hypotenuse of that triangle. That is why anytime they give you one trigonometric ratio, that means they're always telling you 2 of these 3 values right here, and then you can use the Pythagorean theorem to figure out the 3rd. Now, this might be one you guys can do quickly in your head, although 1 and 4 do not make a Pythagorean triple, so we'll do this one slow, although I bet if you tried to make yourself do this in your head, you could. All right, our x-coordinate is 4, square that, plus our y-coordinate of 1, square that, equals r squared. 16 plus 1 is 17, and that is not a perfect square, so all we can say here is that r is the square root of 17. Doesn't simplify any better than that. So where are we here, guys? Let me switch back to purple here. We now just figured out that the radius is the square root of 17, and with these 3 pieces of information right here, we can answer any question that they wanted us to come up with here in terms of sine and cosine and tangent. So back to the first question they were asking, what is the sine of an angle theta? That's our y-coordinate divided by your radius. Our y-coordinate, I found that right here, is 1, and our radius right here is the square root of 17. Now, previously, you guys have been taught, I believe in Algebra 2 and in pre-calculus, you're not allowed to leave an irrational number in the denominator. So you might have learned how to rationalize that by multiplying by the square root of 17 over the square root of 17. And if you do that, that'll get you one form of the right answer here, root 17 over 17. That answer is certainly correct for the sine of theta, but I have really good news for you guys. In AP Calculus, because this is a guideline for the AP test, they don't require you guys to simplify answers, so it actually is okay if you left your answer like this right here. These 2 are equivalent, either one of them is going to work. All right, and now hopefully you're seeing how the rest of this is going to go. Cosine of theta is x divided by r. So look back at my box up here. My x-coordinate is 4. My radius is still the square root of 17, and you can leave the answer like that. Or if you wanted, you could rationalize that to get 4 root 17 over 17. You might have realized over the last couple of years that rationalizing denominators is not as scary maybe as you once thought it was. So at that point, what's the harm? Okay, and then lastly here, secant of theta, everybody. Secant being the reciprocal of cosine. It's just the reciprocal of the answer we just came up with. The square root of 17 is our radius, and then 4 is our x-coordinate. And that one already has a rational denominator, so there's no need to do anything with that. And with just as much work, everybody, we could have found the other two values as well. We could have come up with the tangent of theta, and we could have come up with the cosecant of theta, but these are the only ones that they asked us for. So again, let me just recap here real quickly. Anytime they give you one trigonometric ratio, that tells you two of the three values out of x, y, and r. Then you go to the Pythagorean theorem to find the third. In this case, it was the radius that was missing. Remember that this number always needs to be larger than both the x-coordinate and the y-coordinate. It could technically be equal to 1 if the other one was 0. And that's what we came up with. I should also say this isn't a great question because when they tell you that the cotangent of an angle is positive 4, there's actually two possible ways that one could work out here. We could be dealing with a first quadrant angle, which could look something like this, where we were at the ordered pair of 4, 1. That matches what we had before, an x-coordinate of 4 and a y-coordinate here of 1. But cotangent, like tangent, is also positive in the third quadrant as well. So there's another possibility over here with the ordered pair of -4, -1. And that would have turned, let's see, our sine value, our cosine value, and our secant value all could have been negative. So I suppose technically there should be a plus or minus in front of any of these three answers, but I don't think they were looking for that case. Wait, nope, now that I say it, I'm looking at the directions carefully. It says assume that 0 is less than or equal to, I did that wrong, hang on a second. Assume that 0 is less than or equal to theta, which is less than pi over 2. So that tells us, everybody, that we are dealing with a first quadrant angle. We're not dealing with that third. So all three of those answers should be positive.